Um, Good afternoon, everyone. My name is Mr. Oliver. I teach at Hayfield. I'm going to go ahead and I'm going to kind of go through just the introduction to stuff so that you can kind of get some background. I'll do my best to follow along. I mean, if you want to, feel free to type in the chat. If you want to just kick your mic on and ask me questions, that works as well. So let's go ahead and get sharing. Share screen. Okay, so. First thing I want is hopefully you all know this site. This is how you got in here. Everything that I'm going to be talking about today is going to be in here under statistics resources. Copy the formula sheet for those who would like it. Old resources is when I did this before. This is, I think, third year I've done this, fourth year. But go in here according to the sessions. So today we're session one. We're going to talk about the idea of SOX and DOFs. For those that don't know what those acronyms mean, you will. It's one of the FRQs you'll most likely see, but everything that I'm going to talk about is in here. So the notes are here. I've got a Google Doc that kind of explains what we're going to talk about today. We're going to do an FRQ, kind of talk about it in that context. So let's get started. Actually, let's bring this up. So here, let me go slideshow. Okay, so um, again, your test is going to be Thursday, May 7th at noon. It is a 3-hour test, and we'll have a slide on this multiple choice and free response. So here's what we have. So let me talk about what you're going to be doing. You're going to be doing this hybrid digitally, much like for those who took it last year. What's going to happen is you will be presented the questions on the screen. So you're going to have a charged laptop with you. So what I'd encourage you to do is and it has to be the school laptop, not personal school laptop. So what we need you all to do as teachers is we need you to bring your laptop into the building sometime in the next week or two and turn it on a few times. We need to do updates and get all the updates on your laptop. So please make sure you do that. That's important so that you're not stressing on the day of the test. Make sure it's charged, make sure you have a charge cord, all that kind of fun stuff. But what's going to happen is all the questions are going to be presented digitally, all of them. You'll be answering the multiple choice questions on the screen. You'll be clicking the answers on the screen. When it comes to the free response, you're going to be given a paper book. And in that paper book, you will have a formula sheet. They will give you a formula sheet this year. I know last year there was some kind of discussions about whether they do it. You will be getting a paper copy of the formula sheet and you get some scrap paper. You're going to write your answer in the test book. And what I'll do is on the last day, we're doing a review session on May 6th as well, the day before the test. I'll kind of show you what it looks like visually so that you can understand like what you're going to be dealing with. But you're going to be answering your FRQs in that blue book. So, makeup of the test. This is the last time this is the case. It's changing next year. But for y'all, it's going to be 40 multiple choice questions and 6 FRQs. The 40 multiple choice questions in 90 minutes, so about 2 minutes and 15 seconds a question on average. Free response question, those 6 of them. The thing you need to understand, and we'll spend a day talking about this question 6, the investigative task. They encourage you to spend about a third of the test on that. The main reason is it's a lot of reading, and I'll talk about a little bit more about that as we get to it. So you need to provide a little more time. The other reason you want to do that is that one question is worth twice as much as any other question. So what I mean is like question one, if you were to get if you were to get like a 2 out of 4 on question one, and you got a 2 out of 4 on question 6. That 2 out of 4 on question 6 is going to have a little bit more bang to its buck. It's going to be worth 4 points when they're calculating your amount. So you definitely want to make sure you put pencil to paper on question 6, and I'll talk about that as we go through this. Again, please stop me if you have any questions. I'll happily answer them. When it comes to test taking strategies, when it's with multiple choice, I'm going to let you know. I've been teaching this class for 10 years now, and I've never had anyone run into any really timing issues on the multiple choice. Free response, yes, you can run into timing issues, but not multiple choice. The way you want to do it is there'll be a timer on the screen. You can turn it off if that stresses you out. You can turn it off, but it will turn itself back on. I think at 5 minutes, I think is what it is. At 5 minutes, it turns itself back on and you can't turn it off. So the strategy on those questions is the way you need to look at it is you want to go through and answer all the questions you know first. So what I mean by that is if you're on question three and you're reading question three the first time and you're really not sure what it's asking, skip it and go to question four. Don't burn clock trying to figure out how to answer question three. Because there's a good chance question 32 is something you know how to do. And the last thing you want to do is waste time on those first, like on that question three, staring at it for 5 or 6 minutes when you can, get that question right at 32. So you should go through all 40 questions, answer the ones you know first. Or, I mean, honestly, there doesn't usually happen that much, but let's say you look at a question and you're like, oh man, that question's going to take a lot of time. Mark it for review, go through all 40 questions. Then go back through it. My recommendation is you want to eliminate answers that you know are incorrect. I'm hoping over the course of the year you started to develop a little kind of statistical thought process in the sense of like if I said that I had a 98% chance of winning a game and I asked you what's the probability that I won 3 of 4 games. Well, if I have a really high probability of winning a game, I should also have a really high probability of winning 3 games. Probably not 98, but high. So if I see a multiple choice answer that's like 3%, that's where we're hoping like maybe some of that common sense comes into play. Or, I have a 1% chance of having some disease. What's the chance that 10 people, when I select them, have the disease? Well, if it's only 1% of finding a person, trying to find 10 is going to be really, really unlikely. So that's a small number. So that's kind of what I mean in terms of eliminating answers that you might know are incorrect. You should never leave a question blank. Yes. You get credit for questions right. You don't lose points, you only gain points. Um, any question that asks you like true or false kind of things or all or none kind of things, make sure you read all the choices because I will let you know the way College Board usually structures their answer choices. Like, answer one, like no. Answer two, you're kind of like, well, maybe that could be it. Answer three, no. Answer four, no. Answer five, definitely yes. And it's like if you had stopped at that first one that you kind of felt was right, you might miss the actual correct answer. And then if you have the time, review all of your answers. So that's multiple choice questions, anything. Um, this is where the questions come from. So you can kind of ballpark it. If you multiply these things by 40, you can kind of get an idea of where you're going to see questions from specific units. So I would assume that most of your teachers finish down here with the chi-squared and the slopes if they got to the slopes part yet. If maybe they're going to be doing it shortly. If you actually kind of do those numbers realistically, what that means is there's probably like one question on chi-squared and one question on slopes when it comes to the test. Um, I'm hoping that you've heard this or your teachers have talked about this, what the expectations are on the number of questions you're going to get right. You're probably not going to get 40 out of 40. Very few people get 40 out of 40. The line in the sand that you want to think of is that if you feel like you got 30 out of 40 correct, in other words, miss 10, um, you're probably in the ballpark for a 5. I mean, 30 out of 40 and above, 30 out of 40, 31, 32, that's like a 5. Um, 20 out of 40, so half of the questions right, is a 3. That doesn't mean the test is easy. It means that that bar to get a 3, to get a 4, to get a 5 are kind of brought down a little bit. So just be aware of that as you're going into the test. Please, 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 please don't feel like if you're looking at questions and you can't figure out answers that you're not gonna do well on this. I would tell you that if I were to take the test as a teacher who's taught this for 10 years, I'd probably miss 3 or 4 questions because I just misread a question or things like that. So just kind of have that mindset coming in. Okay, FRQs. FRQs are a little different. FRQs are a timing issue. You really have to kind of pace yourself on this because at the beginning I said that question 6 is 25 minutes. Nowhere in the timer does it tell you question 6 25 minutes. You have 90 minutes to budget. So in other words, 25 of those minutes, they're saying you really should budget it towards question 6, which means 65 minutes you should budget towards the other 5 questions, which means about 13 minutes a question. So here's what I would encourage you to do. I would encourage you to read over the questions quickly, maybe over a course of like 4 or 5 minutes, just scan over the questions, one, two, three, four, and five, and see if there's a question in there that kind of is in your sweet spot. Like, let's say you're really good at experimental design. You know how to, you know, all your different biases, you know, your sampling methods, you really know that. Get that question done first. Or let's say you're an inference person and you're like, oh my God, oh my goodness, they gave me a one sample confidence interval for proportions, and you know you're good at that. Do that question. I would encourage you to do one question and then jump to question six. So it's like do that one question, jump to question six, read over it. I'm going to tell you that parts A and B are likely to be some of the easiest questions on the entire test. And I mean easy and accessible, very straightforward. Is this an observational study or is this an experiment? It might be like interpret this confidence interval in context. It's those things that you've done over and over and over again. A lot of times in question six, parts A and B are very accessible. Then jump back and kind of answer your other questions and maybe come back and finish up question six at the end. I will tell you that usually, and I'll show you the ordering of the questions, it's not set in stone. College Board kind of does like reorder them from time to time. But realistically, what you're going to see when it comes to free response, we're going to skip over this. These are the topics that you're going to see. Describing, comparing distributions or scatter plots. That's what we'll talk about today. That will be a question. Experimental design will be a question. So now we're up to two. Probability random variables will be a question. That's three. Inference will be a question. That's four. The multi-focus question I like to call fruit salad is the fifth one. What that means is it's a little bit of each one of these. It might be like, hey, what is the median of this? Or compare the means of this, or like what would happen if you did this to the distribution. Experimental design, they would say, hey, is this an observational study or an experiment? Probability, they may ask you a basic probability question, just like reading it out of a table. Inference, they may ask you to state hypotheses or something along those lines. And then investigative task. And we'll spend, like I said, the last day, we'll talk a little bit about the investigative task. The ordering is not always consistent. I can update this. 2025 was a SOX, was a describing a distribution. 2024 was an inference. 2023 was a SOX. They don't have them set in stone which one's first. I will tell you that over the last, I mean, I said I've taught this class for 10 years. I will tell you the questions have become much more accessible. There is no trying to understand what the question's asking you. The question is very straightforward in what it's asking you to do. It's whether you remember how to do it that's important. So there's no, sometimes what it used to be is like you have to read through the question 2 or 3 times to try and figure out what did it want me to do. So it's not that anymore. It's like, hey, I want you to do a 2-sample test for means. And it makes it very clear when you do that. So any questions about formatting? Any questions about the formatting of the test? Okay, let me talk about the first thing, describing, comparing. And the acronym that I've given my students to use when they do this, I use the acronym SOCCS, SOCCS. I know some other teachers use some different things, but the way I do it is S, the first S stands for shape. The second S stands for outliers or unusual features. I think CUS is another one that might be used. C stands for center. That last S stands for spread. And notice I put that word context in bold, underline, and italicized. Context is without question one of the most important things you have to do when it comes to one of these FRQs, these free response questions. I can tell you that if you look at a scoring rubric, oftentimes if you forget context, they don't give you any points at all. Some years, yes, other years, no, but I'm telling you, there are years where I see if you don't do context, they don't give you any points. Like if you just say the median is 12. 12 what? 12 bananas, 12 eggs, 12 people, what? 12. You can find it in the picture. We're going to do an example where you can kind of see what I mean when I'm saying you can find it in the picture. So that's what I'm talking about with context. Shape. The way you work with shape, There are three shapes that you should be dealing with. It's skewed right, skewed left, and roughly symmetric. My students know that when I tell them this, I teach them about skewed right. Let me see if I can draw this up here. Skewed right, if you look at your right foot, that's skewed right. So imagine your right foot, that's like your big toe. And then your foot goes off to the side. So your right foot is skewed right. Your left foot is skewed left. What it really is it has everything to do with this tail, the direction the tail points. So the tail here is pointing to the right. So imagine this is like a Tyrannosaurus Rex. The T-Rex's tail is pointing to the right, skewed right. The T-Rex's tail is pointing to the left, skewed left. Okay. And then the only other shape that you're going to be dealing with is roughly symmetric. That's roughly symmetric. What I want you to understand is I really need you to understand the idea of putting this word roughly in front of it. It is roughly symmetric. I can tell you, I can show you the notes on this one from last year. If you describe a distribution as symmetric, what College Board means when you say symmetric is that theoretically you should just be able to fold it perfectly in half. So back to those days where you made your butterfly and when you folded it in half and the wings lined up, that's symmetric. So when you say symmetric, you are implying that it is perfectly symmetric. What I would encourage you to do is put the word roughly or approximately in front of symmetric. Because if something is perfectly symmetric, it is also roughly symmetric. If something is roughly symmetric, it doesn't mean it's perfectly symmetric. So you put that word roughly or approximately in front of it, you're going to get your points. So make sure you put that word in front of it. And there's also one word you should never use when you're describing a shape, and that's normal. Please never use the word normal. There's going to be normal questions on the FRQs and multiple choices. I know this is what we draw when we draw a normal distribution, but when you're describing shape, please never use the word normal. Normal is never going to be the description. It's never. It's going to be approximately symmetric. So that's the first one. Any other questions? Any questions on that? Okay, I'm jumping to center next. I'll come back to outliers at the end. Center, there's two measures of center that you're going to deal with, mean and median. Mean is best used when you have a symmetric distribution. Median is best used when you have a skewed distribution. I use this example with my students all the time. 3 FCPS math teachers walk in, have dinner together. If you were to end, so we're all making about the same salary. If you were to say our distribution of salaries would be roughly symmetric because we're all making about the same. Our mean and our median are going to be whatever, $90,000, just to make up some number, arbitrary number, $90,000. Like one person makes 90, one person makes 95, one person makes 100. So our median is 95, our mean is 95. Now, Elon Musk walks into the door and sits down at the table with us. That's going to mess with our mean because our distribution all of a sudden becomes skewed right. We got one number way out there. We got that dinosaur tail out to the right. So what would be better to use to describe our average salary as our median? Because if you were to add 90, 95, and 100,000 to, 70 billion or whatever it is, you're going to get a mean in the billions. And, a $69 billion mean makes no sense because 3 teachers make a whole lot less. So that's why we use median. However, comma, when it comes to describing a picture, feel free to use median because median's a whole lot easier to use. So like if you get a dot plot or you get a box plot or you get a histogram or a stem and leaf, any of these pictures, median's fine because median's easy to find. It's the middle one. So if I have 70 items, it's 35th and the 36th. Whereas if I had 70 items, I would need to add everything up. The only time you should kind of focus on this is if the question ever says which one is the best measure of center. Okay. Questions on center? Okay, I'm going to jump down to spread. Spread kind of comes off center. If you're using mean as your measure of center, you should use standard deviation as your measure of spread. If you're using median as your measure of center, you have 2 choices. You can either use range or IQR as your measure of spread. And the formulas are here, max minus min for range, Q3 minus Q1 for IQR, so the third quartile minus first quartile. Now, please be aware that the range is not 10 to 20. The range is 20 minus 10 equals 10. I'm just making up arbitrary numbers. If my quartile 3 is 15 and my quartile 1 is 2, the IQR is not 2 to 15. The IQR is 13. It's the number 15 minus 2. That will be a place where you can lose a point. You should never put a spread of numbers down, like a range of numbers down for range. You should put one number down. Okay. And last, outliers or unusual features. Let me get unusual features out of the way first. An unusual feature would be a hole. So for example, let's say a histogram, and the histogram kind of looked like this. And what I had something that kind of looked like this. I'd want to talk about that hole right there. That's a hole. Okay, that's one kind of unusual feature. The other thing that you could have is you could have multimodality. So what I mean by multimodality, let's go back. Here's how we have our multimodality. That's got 1, 2, 3 most common numbers. That's multimodality. So that's what you're dealing with when you're talking multimodality. So that's your unusual features. Occasionally they happen, but I'm going to say it's not a regular basis thing that they have multimodality. Okay. So now the other thing we got to deal with are outliers. And when it comes to outliers, what I need you to understand is when it comes to outliers, there's two ways to compute outliers. There's a way using means and there's a way using IQR. The way you do it during means, and this is usually going to be if they give you a table of values at the bottom. Like usually they say, hey, here's the number of data points, here's the mean, here's your standard deviation, here's the minimum, here's the maximum, here's the quarter. They just give you a whole bunch of numbers at the bottom. If they do that, you can figure out the outliers by taking the mean, adding 2 standard deviations, subtracting 2 standard deviations, and those give you the fences. Anything in between the fences is not an outlier. Anything outside the fences is an outlier. So that's one way. The other way that you're going to deal with it is with IQR. And IQR is like, if you think about a box plot, what IQR is, just so you can kind of visually see what I mean when I say box plot. So this is a box plot. Rudimentary box plot. IQR is the size of this box in the middle. So that's what it is. It's Q3 minus Q1. So the way you figure out those is against putting fences up. You take the IQR, you multiply it times 1.5, subtract it from Q1 to give you the low fence, add it to Q3 to get the high fence. Anything in between is not an outlier. Anything outside the fences is an outlier. And if you happen to fall on the fence, not an outlier. So whether it be mean, the standard deviation, or IQR, if you're on the fence, not an outlier. So that is what you're going to be doing on those. And the last thing, and we'll talk about this in our example I'm going to bring up in a second, it's very, very important when you're asked to compare, and the word compare will be there. You must use phrases like is greater than, is smaller than, is bigger than, is larger than, is slower than, is faster than, is roughly the same, is equal to. Anytime you ask compare, you need to use those phrases. So if I said that my median was 10 and my wife's median was 12, that's not comparing. My wife's median is larger than my median. That's what you want to say. Any questions on that? I know that's a lot to process in a short period of time. I think when we look at the picture, it'll help a little bit. Okay, here we go. We have 2 box plots. And again, my recommendation when you're looking at a question like this on FRQs, oftentimes I kind of read the question first, or what they're asking you for first, and then read what it's about. So compare the distributions of gas mileage for the samples of cars manufactured in country A and the sample of cars manufactured in country B. So what I know is that this is all about cars. So now, if I'm asking a question and I'm letting you, and the question is asking me like, hey, I need to, What I need to do is I need to be able to know what I'm going to be dealing with when it comes to context. Let me just kind of tell you your context. That's not good. Your context is always going to be the stuff down here. So what I mean is, go back to my pencil. Here. So this right here is always going to be my context. Right down here is context, gas mileage, miles per gallon, and countries. Okay. But now we need to compare it. So when you compare it, there's a couple things you need to compare. And if you just hang on 1 second, I'm going to sneeze, and I do not want to sneeze in your guys' ears. Apologies. Okay, back. Okay, so if I were to compare, thank you. If I were to compare those two centers, how would you think I'd go about comparing those two centers? Feel free to type it in the chat, or if you want to turn on your mic, feel free. Let's hear someone else's voice or someone else in the chat. How would you compare those guys' centers? Okay, feel free to type in the chat or just turn on your mic and say it. Either one's fine by me.
Countries 8 has a center at 16 or at 18, which is less than country B, which has a center at 32.
Almost there. There's only one thing you forgot: context. 18 watt and 32 watt.
Gas mileage.
Yeah, so gas mileage or miles per gallon. So yeah, that's the only piece that you're missing that in this case wouldn't have cost you a point, but you got to be careful. Anytime you give me a number, never give me the way I like to say it's a naked number. 18 is a naked number, 32 is a naked number. 18 mpg, 32 mpg. But other than that, spot on, perfect, exactly what you needed to do. Exactly what you needed to do. You said the country A's was smaller than country B's. Perfect. If you said country B's is larger than country A's, perfect. But again, it's country A's median is smaller than country A's median miles per gallon. And notice, I didn't have to put the numbers in there. I'm going to let you know you don't have to put the numbers in there. I'd encourage it because when you put the numbers in, it kind of helps you reinforce in your head when you put in 18 miles a gallon, 32 miles per gallon. It helps reinforce in your head that you're actually doing the right comparison. Oh, and just so you know, inequality signs are fine. So like if you did country A, 18 miles per gallon, less than country B, less than sign country B, 32 miles per gallon, that's fine. That's a comparison as well. What about if I was asking you to talk about the spreads? Who's got the bigger spread? There's two answers that I will take for this. One of them is range. Who's got the bigger range? What's country B's range? Its max is 18. Its min is, what's going on here? Its min is, and this one, if we were looking at its max is 40, its min is 18. 40 minus 18 tells me country B has a range of 22 miles a gallon. What about country A? I'm hoping everybody sees country A's minimum. The smallest value is 14. What's their biggest? We got here. Yeah, their smallest one here. Because what in this case, be careful. Their maximum value is that guy right there. That guy is their maximum. Be careful because 30 minus 14, you might want to say 16. That is their maximum value. But what does that little dot mean? That dot means it's an outlier. It's an outlier. Is a member of the distribution. That number is part of the gas mileage. There's a car that has really good gas mileage in country A. So I would include that. So that would be 38 minus 14. The range here would actually be 24. So this guy's range would be 38 minus 14, which is 24. This guy's is 40 minus 18, which is 22. So country A has a larger range miles per gallon than country B because 38 minus 14, 24 is bigger than 40 minus 18, 22. However, if you did IQR, you would get a different answer because IQR compares the size of the box. And in this case, you can clearly see that IQR, the country B's box here, is larger than country A's box here in miles per gallon. So if you had told me country A had a larger range miles per gallon than country B, good. If you had told me that country B had a bigger IQR miles per gallon than country A, good. Both of them are accurate descriptions. It just so happens that they had different numbers. Okay. Questions about that before I go forward? Any questions about that? Okay. Outliers, we talked about it. Does one of them have an outlier? Answer is, yeah, this guy's got an outlier. When you're defining an outlier, you can give the value, but at the very least, you should give it a location and a count. Country A has one high outlier. That's all I need to do. Country A has one high outlier. Okay. And then the last thing we haven't talked about in SOX is shape. And I'm going to be honest with you, when it comes to shape, box plots are really bad about shape. Box plots are really, really bad about shape. So when it comes to a box plot, oftentimes, College Board isn't going to assess you on shapes of box plots because you can't tell. Because I could come up with a set of data. A lot of people would say this kind of feels maybe symmetric, maybe a little skewed left, but I could probably come up with a data set that kind of had that bell-shaped curve to it that would meet this. So we usually don't do shape on box plots. We will do shape on histograms, the little bar thing. We will do shape on dot plots. We will do shape on stem and leaf plots. We will do shape on those because it's a little easier to see in a histogram kind of thing or in a dot plot kind of thing, but not so much in box plots. So what I want to do is I want to actually show you what the scoring rubric looked like on that. So I'm going to go and bring up the scoring rubric. So I want you to see what the scoring rubric looked like. And okay, so I hopefully did have, just let me know, did your teachers actually go over the scoring rubric with y'all when you were doing this in class? Have they ever talked about the scoring rubric? Okay, that's a shame. I wish they would because it does help. It helps you visualize what College Board is typically looking for. So yeah, it's a good mix. I see mixes of yeses and nos. Okay, so let me show you what happens. I'm a reader. I grade these things. So I'll be going back for my 6th year this year to grade these things. And what I get is I get one of these when I show up. They assign me a question and I grade a question for an entire week. So I might grade like 1,800 of these questions in the course of a week. So I get this rubric. We grade things on this idea of something called an E, a P, or an I. E is like, hey, you got the answer right. P is you're almost there. I is you missed the boat on that. And the easiest way to think about it is in your head, think about E like 1 point, P like a half a point, I like 0 points. And you want to try and maximize as many E's as you can get and get a few P's if you have to. Now, this model solution over here on the left, nobody ever gets this side. That's like the picture perfect answer. Very rarely are we ever going to see this answer. This is how we score it. So what happens is I'm looking over here at the scoring. So what happens is on this question, on the first part, and that's all I'm looking at right now is the first part. It was looking for three of the following four components. You directly compare the centers of the distribution. So when we said that the median of A in miles per gallon was smaller than median B, check, we got that one. Directly compares the spread, either IQR or range of the two distributions. We did that. Check. Indicates gas mileage of one of the cars manufactured as an outlier. Check. So right now, even though we didn't give any context, we would have got the E on this. But that last point is giving me context. Country A, country B, gas mileage, miles per gallon. Please be aware, this was not a normal thing. Normally, what we see, and I see this is the way the scoring is, you get two of these three along with four. You have to give context and give me two of the three, you get the credit. If you only give me these three, I've seen rubrics that only give you a P for that. So please make sure you give context. This one was nice because they were nice and they didn't make you have to do context. Okay. Partially correct says it satisfies two of the four components. What it means is you gave me context and you compared the centers, and that's it. Incorrect is it doesn't meet the criteria of ERP. This means you give me one or nothing. So this is how I grade it. I look and see, did you give me a comparison of means or of centers? Did you give me a comparison of spreads? Did you give me an outlier? And did you give me context? And as long as I saw three of those four things, I was going to give you the full credit. And the thing that we actually end up looking at mostly down here is scoring notes. This is kind of the things we see as we grade your papers. You didn't need to have specific numerical values in order to get credit. So that was just one of the things. You didn't have to do that. If you use the word mean, you didn't get credit at all because when you look at a box plot, you cannot tell the mean of a box plot. It just doesn't exist. It's impossible. Any acceptable mention of shape. So here's the thing I need you to be aware of. This is a new thing last year that they did. Acceptable. Usually what it used to say was, we used to say, ignore any discussions of shape. Like literally that's what it said. It said, any discussions of shape, ignore. This one says, ignore any acceptable. What it means is, if you had talked about skew for one of them, if you had talked about approximately symmetric for the B, we just ignored it. However, if you gave me a bad description of shape, what it meant is I couldn't give you the E. The best you could hope for is a P. So this was a little different. This had a little different hook on it. This is the thing I want to show you about when it comes to comparison. If you do not directly compare them, you can't get components 1 and or 2. So in other words, if I said that the median of A was 18 and the median of B was 30, that's not a comparison. I'm not going to get 1. If I said the range of this guy is 22 and the range of that guy is 24, not going to get it because I didn't compare. So that is how we score these. They're really nice in terms of it. At this point, if you haven't looked at them, just listen to me talk about it and kind of move on. If this is something you talk about in class, look at these things because the scoring and the notes oftentimes come in handy. So. Got here. Okay, so questions for me. Let's go back to the question. So, next question says, for the distribution of gas mileage, would you expect the mean for country A? Would you expect the mean to be greater than 18 miles per gallon, less than 18 miles per gallon, or equal to 18 miles per gallon? So, let me be honest with you. If you're ever asked to answer a question like yes or no, increase, decrease, stay the same, even if you have no clue whatsoever what the answer is, pick one. Because if you randomly guess right, you might find your way to a half a point on a question. So now I'm asking you the question. This guy has, we're asking you, would the mean be greater than 18 miles per gallon? Why do you think they picked the number 18 miles a gallon? Why do you think they went with that number? What do you think the thought process was that country A and 18 miles per gallon? Why did they pick that?
Because that's the center or the median on the box plot.
Right, that's the median. So, and what you just did when you said that, you just got yourself one of the components. By identifying that 18 was the median, bang, you got yourself a point. And the nice thing is, If you had said that in part A, that the median was 18 miles per gallon, follow on credit down to part B. So now I saw in the comments, what can we say about this distribution? Does this distribution look skewed at all in terms of this? So does it look like it has a tail one way or a tail another way? Yeah, this guy looks like he's got a tail kind of pointing to the right. This is the Elon Musk situation. So what do you think is going to be the mean of that guy in terms of 18? Is it going to be bigger, smaller, or the same as? Elon Musk sat at the table with us. This is what's happening. This is Elon Musk. My mean is going to be larger than 18. And that's really what it was looking for. It was looking for you understanding that. And let me kind of draw a picture so you can see what I mean. So here to my annotate and get some pencil. Okay, so here's what I mean. When I have a roughly symmetric distribution, my mean and my median, so here's my median and here's my mean, are going to be about the same. And you can make up a very easy example if you want to. 1, 2, 3 is a data set. 1 plus 2 plus 3 is 6. 6 divided by 3 is 2. Mean is 2. 1, 2, 3, median is 2. So they're equal to one another. What you're going to find out when you deal with skew is that the median will always be in the middle of the data set, but the mean will go towards the tail. So in a skewed right distribution, mean goes to the right. In a skewed left distribution, so I had something that kind of looked like this. Again, my median is in the middle. My mean is going to be going to the left. And that's what that one was asking about, if you understood that. Yep, perfect. Perfect. And again, the whole idea of answering a question and what I'm trying to be clear to you about is this. Even if you are not sure, guess. Blank is wrong. You never know what you're going to get when you guess. So please guess. We'll talk about that in a minute. I want to make sure I can get through this. Well, I don't know if I'll get the DOFs to there or not. I might just record a quick video for DOFs later. Okay, so let me be clear. The way this question's worded, answer A is a very accessible question because it's literally the first thing we talk about in class. Most of us as teachers, if we don't, some of you started with experimental design, I know, but realistically, one of the first things we talked about, so like August, September timeframe, we talked about describing these distributions and comparing these distributions. Question B is kind of digging a little deeper to see if you remembered when your teacher told you that when the mean always goes towards the tail, so the mean will be larger than the median skewed right. The third one and the last one is really, honestly, it's kind of pushing people to see if you really got your stats knowledge down. Bring this down here to the bottom and make this a little bit smaller. Okay, so now I want to roll everything together into one distribution. So what I mean is this question says, I want to do country A and country B and mash them together. And then it says, what is the range of the combined data set? Well, I'm hoping y'all remember with range. Range is biggest number minus littlest number. Well, when I combine these two distributions, that is my max. And when I combine the two distributions, that is my min. So their combined range is 40 minus 14, or 26 miles a gallon. So I'm mashing them together and it's biggest minus smalls. So that first little bit is kind of setting you up to hopefully kind of get what the answer is looking for. Now, I got a couple people in the call from my actual class here, and they've already heard me talk about this one. The second one is a little bit trickier. What is the median? So let me ask just in general, what's the median of something? What is the median?
Like the middle of the data set.
The middle of the data set. Okay, so if you read this thing up at the top, it says there is 100 cars here in A, and there are 100 cars here in B. If you can remember from a box plot, box plots are, it's the middle. It's 50% into the data. So what it says is from this start point here to the end point here, there are 50% of my cars, which just so happens to be 50 cars. Because 50% of 100 is 50. Well, these are all broken out in what are called quartiles. So what do you think makes up a quartile? It's right there in the word. What is a quarter?
25%.
Yep. And 25% of 100 is 25. So what that tells me is that every one of these little components has 25. This has 25. And just so you know, that right there is 25. What it means is that there's 25 in this little whisker right here. There's 25 in this half of the box. There's 25 in this half of the box. And there's 25 in this half of the box. So if I were to roll these two countries together, how many total cars do I have? 100 plus 100 is
200.
200. And where would the median of 200 cars be?
Yeah.
What number car? Don't worry about the number in the graph. What number car would be the middle of 200 cars?
100.
100. And so what I'm going to do is I'm going to start counting from the left. I've got 25. I've got 25. I'm now up to 50. I've got 25. I'm up to 75. But I also have, if I mash these two guys together, these 25 down here, 1, 2, 3, 4. That tells me that this number right here is my median. My median is about 24 miles a gallon. So let me be clear. That's nothing we as stats teachers have ever taught you. We really didn't teach you that. We never taught you, hey, combine the two and come up with a new median. We never did that. However, it's built on stuff we did teach you. We taught you how to find the median of a distribution. We said, hey, it's halfway through. If I have 100 items, it's the 50th item. A quarter of the way through the data, that's 25 items. And as you notice, they gave us a really nice number. They gave us 100. I will tell you that traditionally, if they're going to ask you to do that College Board wise, what I'm going to tell you is they traditionally are going to give you a manageable number. What I mean is they're not going to give you 38 items and then ask you to combine two distributions because it just gets messy. They're going to give you 100 items, 1,000 items, 500 items. They're going to give you a number that you should be able to relatively easily find a median of. So if I had 500 items, it's 250 is my median. 125 is a quartile. These are numbers that you should be able to come up with relatively easier. So, what I'm going to do is, because we only got about 10 minutes left, is I'm going to show you the scoring rubric on this one, just so you can kind of understand what you're looking at scoring rubric wise. And what I will do is I will do a DOFS kind of thing for the rest. I will do a DOFS. I will do a video for DOFS, and I'll make sure it gets posted up here so you can kind of watch that. I'll make it tomorrow during my planning period. Okay, so let me just show you the scoring guidelines on this so you can understand how we score this. So here's the question about mean being larger than median. What they're looking for indicates that the mean of A is expected to be greater than 18 miles per gallon. So as long as I picked one of the three, the correct of the three answers, I got one of them. Number 2 indicates 18 is the value of the median. Number 3 provides a reasonable justification for the relationship between mean and median based on right skew distribution or the expectation that an outlier in the right tail will pull the mean above the median. So in other words, if you said it was skewed right, mean greater than median. If you said, hey, that big outlier messes everybody up, that's Elon Musk sitting at the table with me, that's a reasonable explanation. What's partially correct is if you get component 1, you had to pick the right answer, and you had to give me a right reason. Or you had to say the median was 18. And it was incorrect if you didn't meet either of the above criteria. And what the first one says is, as long as you said 18 somewhere, so if you said 18 up in A, congratulations. The medium country A was 18 miles per gallon in part A or part one up there. You got the credit for part B. Weak explanation is if you described it as skewed. If you said, oh, the distribution's skewed, so mean is greater than median. Skewed in what direction? I mean, like skewed right, positively skewed, that kind of thing. This is my favorite one I talked about in class, just so you understand what this means. If you gave a correct numerical justification, and I had a friend who actually graded this question, just so you know what the person did, and I wish I was kidding, they literally came up with 100 values that would make this box plot. They literally wrote down 100 values that would make up that box plot, and they averaged all 100 of them together, and they got a number bigger than 18. Someone actually did it. I would not encourage you to do that. That's a whole lot of wasted time and effort. No, so what this guy is basically saying is that if you actually physically went and came up with 100 numbers and averaged them, and you'd find out it was greater than 18. But man, that's a lot of work for very little. So that was looking on that one. So far we had, an EP or an I for one, an EP or an I for two. And then part three was looking for four things. You had to get all four to get the points, to get the full points. You had to say 26 miles per gallon as the range. You had to give a justification that talked about the max being 40, the min being 14. You had to calculate the correct median. You had to have a correct justification. However, if you look at the partially correct, you only had to satisfy two or three. So in other words, let's say you knew how to do range, but you couldn't do median. If you did range correctly, you would have gotten a P on this question. So in other words, what it's saying is if all I had done was correctly identify the range, I could have gotten a P. Or if all I did was give a number and a number, but not an explanation, I could get a P. And again, the notes sometimes are kind of nice to see. They gave us a range of things. So they were like, if you misread the chart by like one either way, they were kind of nice. So like if you read this chart here and you read this as, say 13 to 15 is what they said, is if you read this anything from 13 to 15, if you read like this guy here, and some of them are here, like if you read this guy, it's like somewhere between 39 and 41, they gave you credit for just, they're not penalizing you for being off by like a one, and that's what that really means. And the last thing I want to show you, and then I'll kind of ask you if there's any questions. This is how we assess. So you had three parts. You could have gotten an E, 1 point, P, half a point, I, 0 points. So if you add it up, it doesn't add up perfectly, but what it says is if you get all three parts essentially correct, if you get 3 points, we're going to give you the 4. If you get 2 parts essentially correct and 1 part partially correct, so if you think E is worth 1, so 2 E's, 1 and 1 is 2, and a partially correct is a half, that's 2.5. We'll be nice and round up to 3. And we round up in all but one case. Most of the stuff falls into the 2 categories. So again, if you got 2 E's and an I, 1 and 1 is 2. That's why you get a 2. 1 part essentially correct, 2 parts partially correct, 1.5, and another half is 2. 3 parts partially correct, 1/2, plus 1/2 is 1, plus 1/2 is 1.5. We're going to round up to 2. What you get for a 1 is 1 part essentially correct, no parts partially correct, so that's your 1. This one says if you got 2 P's, so a half and a half is a 1. Notice the only thing you don't get credit for is if you got 2 incorrects and 1 partially correct, that's 0 plus 0 plus 0.5, that's 0.5. They don't round that up to a 1, they round that down to a 0. So everything rounds up except like a half. And realistically, if you think about it, if you only get half a point on a question, you really have a hard time giving someone a full point on it. And just so you know, the average score on this, and there were people in my class that saw this. Let me see if I can actually get it. I don't think I have it on this one. I have it here. The average score on this question was, draw it so you can see. The average score on this question was 1.75 out of 4. And that's more likely the case for just about every question. There is very rarely, if ever, a question where the average score is anything as is 2 out of 4 or higher. Very rarely. I think it's been maybe once or twice in the last 4 or 5 years. So most of the time, you're gonna an average score, mean score is 1.75. So in other words, what that's trying to say to you is this: if you're getting 2 out of 4 on every question, you should be doing cartwheels down the hallway. Because if you're getting 2 out of 4 on every question, you are definitely a 3, probably smelling a 4. Again, not that it's easy to get 2 out of every 4, but if you are getting 2 out of every 4, you are definitely a 3 and above. 50% and above is a 3. 67% and above is a 4, 75% and above is a 5, roughly. Again, please don't hold to that number. It's roughly in that ballpark. It's kind of a good idea. Some years it might be 72% is a 5, other years it might be 76% is a 5, but that's a really good way. Half, 2/3, 3/4. You get half of the test right, you're a 3. You get 2/3 of the test right, you're a 4. You get 3/4 of the test right, you're a 5. So, any questions for me? Any questions?
Is there a certain decimal place we're supposed to round every time?
My piece of advice is this: always go to 4. Here's the reason why. Because in the case of means and medians and stuff, if you went to 1 or 2 decimal points, it's not the end of the world. But when you get to p-value, 4 decimal points is important, because when you're going to look for that significant level, that 0.05, you want to go 4 points because it'll give you clearer idea of a p-value. So I usually tell my students this: just go to 4 decimal points, because if you always go to 4 decimal points, you're always going to be right. Does that make sense what I'm saying?
Yeah, it makes sense.
Yeah, if you were to tell me 14.2 miles per gallon, I'm not going to say anything. But if you went to tell me a p-value was 0.2 rounded, I'm going to say something to you about that 0.2 rounded. I would rather you have 0.1942. Like, I would rather you have something like that. So, any other questions, folks? Anything? It doesn't have to be about the stuff we talked about today either. It could be just in general, any sorts of questions. Okay, here is what I will do. I will make up a video for the other part of this. I didn't get to DOFs. DOFs is describing scatter plots, and I saw the timing. I don't want to rush through. So what I'll do is I'll make up a video for DOFs, and what I'll do is I'll post it in this folder. So all of you found your way here, I'm assuming, through this website. I'm assuming most of you found it through here. If you didn't, let me know, and I can let you know how to get there or join it. But what I will do is, for these resources for session 1, I will record a video on DOFs, probably 10 minutes, and I'll post it so that you can have a little bit of DOFs. So what it'll do is it'll be in this folder. This recording will be up online as well at some point if you want to go back over it. Feel free to email me if you have questions. So let me just do this. 1 second. That is my email address. If you feel free to email me at that. If you have any questions, I'll happily answer them for you. But other than that, I think that's what we got for today. Let me kind of stop this recording.